Good afternoon. Finishing up descriptive statistics. So we spent the last 3 classes looking at representing data graphically. 4 classes, right? Started with the box point. While visual representations are great, they can also be used to mislead. So there are 3 very common forms of misrepresentation that are used. First one is an incorrect position of the vertical scale, an incorrect origin. Second is an incorrect sizing. And third is a misleading position for 3-dimensional diagrams. We're looking at each one. Baseline is the height at which the horizontal intersects with the vertical. And so we can mislead if we set a baseline other than 0. So as an example, average cost of a house per year from 16 to 19. It's given here. Notice here that the baseline is 0. Right, your vertical starts at 0. And you look at this, and the average cost has gone up from 16 to 19, but not that drastically, relatively speaking. Versus the exact same data. Baseline is now not 0. Baseline here is 345,000. And then we change the scaling. Now it looks like it's a much more dramatic increase. Generally speaking, when you look at a graph, you're not really examining it too much. Right? You just kind of look without looking at the axes or anything. You go, oh my God, that's a huge increase. Second is with the sizes. So there's what's known as an area principle. So if you're using a mouse to construct an image, the areas of the images should be proportional to the amounts. Example, if one amount is twice as much as another, the image should have twice as much area. Easiest demonstration, think of a rectangle. What's the area of a rectangle? Area of a rectangle. What is it? What happens if you double both length and width? What happens to the area? How much? If I double both length and width, what happens to the area? Area won't double. Quadruples. Twice the length times twice the width. 4 times length times width. And that's just a rectangle. When you start to get some more complicated shapes. Right, so average sale price in 1990 was, let's just say 150. 2020 it was 300 and, again, round up, 390. It's about 2.6 times the price of 1990. But if you look here, that 2020 image is more than 2.6 times the area of the 1990. So again, this is probably one of those situations where, if you're familiar with, once you paste an image, it kind of always comes out in a square. If I just double both length and width of that square, and finally, 3D graphs. As a general rule of thumb, you shouldn't use 3D images anyway. Because it's not possible to really represent anything three-dimensional on a two-dimensional sheet of paper. But when you do 3 dimensions, you generally have to pick a viewpoint. Depending on how you pick the viewpoint, it can make things look larger or smaller than they really are. Like I said, as a general thumb, just don't use 3-dimensional images. So average house cost for 4 years, 16, 17, 18, 19. Calculate absolute and percent increase from 2016 to 2019. We'll start there. Absolute increase is fairly straightforward. What's the house price in 19? What's the house price in 16? Take the difference. So what, 390 minus 345. And quickly, you should be able to do that. What's that difference? 45,000. That is our absolute increase. Percent increase. Absolute change divided by the initial value. And then, since you want 100%, multiply by 100%. Wait for that calculator. About a 13.04% increase. Round down, 13% increase. Okay, so now bar chart uses a truncated vertical axis from 340 to 390. What fraction of the axis height represents the 16 to 19 change? Well, we already know the change. It's 45,000. But the vertical axis goes from 340 to 390. What's that height? $340,000, $390,000 and stuff like that. With a length. What was it? 50,000. Real simple, right? It's just the range. So they're asking for fraction of the axis height that represents that change. It's just 45,000 divided by 50,000. would make it look like it's a 90% increase. Well, I'm sorry, that's just 90% of the axis is the change, not increase. I'm not going from there to there. If instead we start at 0 fraction of the axis height that represents the change, right, well now starting at 0, height of the axis is the full range, isn't it? Now that percent of the axis height that represents that change, 45,000 divided by 390,000. It's about 0.1154. Or 11.54% of the axis height is the difference. Finally, they want the exaggeration factor. Okay, so how much is that increase exaggerated if we have a baseline of 340 instead of 0?
Thank you.
All it's going to be is the fraction of increase from the truncated divided by the fraction of increase from the full. 0.90 divided by 0.1154. $7.79896. Let's just say 7.8. What that is saying is by using a baseline of 340 instead of 0, we've made the change in price from 2016 to 2019 look 7.8 times larger than it really is. Line chart, same house prices. Highlights year-to-year change. why would a non-zero baseline be acceptable for this, but not a bar? So a line chart is just a line, quote unquote a line. What you do is you just take the values. So for instance, 16, 17, 18, 19. You plot them as points, and then you just draw lines that connect each point. And so it's really just a collection of line segments. Unlike the bar graph, right? The bars are representing a length of a specific value. Right, so notice that the bar is always starting on the horizontal. So it'd be like something like that for the first. Whereas all the line graphs do is connecting points. Right, the line graph is showing a trend. So actually a non-zero baseline might be better to show a trend. You can kind of really zoom in on that line. But just be careful. You still want to clearly label your axes. And so using the same data, if 2020 house icon is drawn with linear dimensions, 2.6 times the 1990 icon, by what factor will its area grow? That is, we're assuming it's rectangular. If that's the case, it's going to grow by 2.6 squared. $6.76. So the area has grown by 6.76 times. So by what linear factor should the length and height be scaled? If it's 2.6 times, length times height, S length times S height to represent the scale. That's S squared, length times height, which is obviously just S squared times area. We want that to be 2.6 times the area, right? So your linear scale would be the square root of 2.6. About 1.61. If you wanted to increase both dimensions the exact same amount, be about 1.61 times each one. And you should probably keep the dimensions the same. Well, instead, let's say that we're representing two categories with circles. R sub A, radius for A, and R sub B, radius for the B. The volume of circle. Oh, no, I'm sorry. That's not area. That's value of A is 40. Value of B is 90. What should the ratio of RB to RA be to satisfy the area principle, right? Remember that means that if B is X times A, then the area representing B should be X times the area representing A. Well, first, what's the area of a circle? Think back to geometry. What is it? There's definitely R squared in there, but it's what times R squared? What is it? Pi R squared. Do you know what the exact value of pi is? It's not the exact value. It's a trick question. We don't know the exact value because it's irrational. I think they calculate quite a few digits though. Like that's actually a research topic in math is just to calculate the digits by. So as of 2024, 202 trillion digits of pi have been found, which is still nothing to the number of digits it has. So for A, what we're going to want is the area of B to the area of A has to equal the ratio of the value of B to the value of A. Oh, well, that's nice. Pi over pi is 1. So the square of the radius for B to the square of the radius to A has to be 9 to 4. Then the ratio of 1 is 3 to 2. If an illustrator just doubles the diameter for B, what apparent ratio is implied? Well, this is what we have, right? You're just doubling the radius. So there would be pi times twice that radius squared. What's 2 squared? Ratio would be 4 to 1. Versus what it should really be. Well, we said what? That radius of B should be 3/2, 1.5 times larger than the radius of A. (1.5 squared). What's 15 squared? I don't know. What is it? $225. So 1.5 squared is 2.25. The true area ratio should be 2.25 to 1, not 4 to 1. It's about 1.8 times larger than it should be. .3D column chart titled, so the bar tops that should be received. What happened to my extra E? And so category B has a true value of 60, looks only 15% taller than category A, which is a true value of 50. What is the true ratio of B to A? Yeah, that's easy, right? B to A is 60 to 50. Six to 5. Which is what, 1.2 to 1. What ratio does a 15% perceived increase represent or imply? $1.15 to 1. Slightly less. And why is 2D preferable here? Because the 3D the 3D, right, makes everything look shorter, depending on your viewpoint. So if you're staring at it, so they call this from above. I call that from the front. If you're looking at it that way, the bars actually seem to be a little bit shorter than they truly are, right? Which is obviously going to make any difference look smaller than it really is. So 2D is preferable. All right, we have a bar chart, quarterly totals, baseline of 9 instead of 0, making tiny differences look huge. 2 fixes. First one's obvious. One of them's obvious. just use a baseline of 0. Second fix, you could also just use a line chart instead of the bar graph and keep the same baseline. You could also annotate your percent increase right within the bar graph. We keep the bar graph and you use baseline 0 and again, if you annotate the percent increase, you can keep the baseline. Questions on misleading graphs? So in other words, when you're trying to give a visual for your data, you want to make sure it's not misleading. If you want to be trustworthy. And if you're just being paid to try and persuade someone one way or another, then maybe. I don't know how much they're paying. For my reputation, I've been made at least 50 million advanced. And I never work again a day in my life. First test is available now. It just covers the descriptive statistics. Right, so sections A through H. I do have a review folder up here as well. And as I do out of order, you're always changing order on me. A review worksheet with these solutions are both available. I would recommend you go through that worksheet. It's probably going to be a really good indication of what's on the test. As in, I wrote the test, and then I just had AI generate a review worksheet based on the test. You are going to have several notebooks that you're going to need. I'm not requesting hand sketching for an online test. You're going to have to use Excel to do any kind of the visuals. And I think it's also going to ask you to calculate some of the measures from this data, so you're just going to use Excel for all that. And if I remember, I'm going to want your Excel file for each of those questions. Then I can check the formula that you're using. If you want to save time, well, first, obviously, you want to read the instructions before opening the test. Because once you open the test, the timer starts and you can't stop it. It's a 90-minute time limit. I think it does say in there, I think I put in there, recommended that you actually download and open all 4 of those files before starting the test. This way you have them. He said once you open the test, the timer starts, you cannot stop it. So it will have to be completed in one sitting. But you can use anything you want. Oh, notes. You just can't let Google the answer. And obviously Excel, because I'm going to be trying Excel for this. Also, it should go without saying that this assignment, the tests, are not part of the accepted or the eligible assignments for the late. So it is set to be due on October 7th at 12 p.m. If it's submitted at 12:01, it's a 0. It's late. Also, again, read the instructions, because if you do not follow the file formatting, except the name, I don't really care how it's named, then it's not going to be graded. I only want 1 notebook per question, and I only want the work for that question in the notebook, not notebook, Excel file. But it shouldn't be that difficult. It should be fun. First test is probably the easiest test this semester. There's a lot of vocabulary involved. There's also a lot of Excel files that you can just let Excel do the work for you. Don't worry, I already wrote the second test and you're not using Excel at all. Oh, I lied. You will be using Excel for 1 question, I believe, the regression question. But most of that test is all probabilities. Excel's not going to help you on that. Any questions? I don't remember exactly. There's 4 file uploads, and I think 10 vocab. That sounds about right.
Sounds good.
Anything else? They don't have the no one, which is cheap. Because that would be my voice ringtone. But they don't have it. Okay, so get into your group so I can give you the worksheet. But then after you get it, if you want to just look at the review worksheet for the test, that's fine, whatever. The rest of this time is yours.
Okay.